Okay, Wildcat, so we're looking at Friday, March 29th, logarithmic function transformations on page 66. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look. Notes. Logarithmic transformations. F of x equals negative a log base 2, parentheses negative bx minus h plus k. The negative in front of the a reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative in front of the b inside the parentheses reflects over the y-axis. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. When it's minus k, it translates down. Who would update your notes? Now your notes are updated. Let's take a look at the examples. All right, logarithmic function transformations and inverses. Graph the exponential function by transformations. Find and graph the inverse of f of x. So this is an exponential function. Now, I'm going to graph the exponential function in orange, and I'm going to graph the inverse in green. All right, so the transformation of the exponential function here is down 5 units. That means the asymptote was at y equals 0, now it's at y equals negative 5. Now, the y-intercept for the exponential function here is when x equals 0, so f of 0 equals 2 to the 0 power minus 5. Well, 2 to the 0 power is 1 minus 5 is negative 4. So your y-intercept is 0, negative 4. Now, you know with an exponential function that the curve lies like so. Now, the domain of the exponential function is negative infinity to positive infinity, and the range is negative 5 to infinity. All right, now the inverse of the exponential function is a logarithmic function. Okay, so we know with inverses, the asymptotes switch. So it was y equals negative 5, now it's x equals negative 5. The point was 0, negative 4. Now the point is negative 4, comma 0. Now the domain, remember, switches. So the domain was negative infinity to positive infinity. Now the range is negative infinity to positive infinity. The range was negative 5 to infinity, so now the domain is negative 5 to infinity. Now, before we finish graphing the logarithmic, we want to graph the y equals x line, because you know if the inverses, they reflect over the y equals x line. So the logarithmic function is like so. All right, so go ahead and finish up example 1. All right, let's take a look at example 2. Now, the transformations, looks like we have 2. We have right 1 unit and up 3 units. Now, we know that the plus 3, that means our asymptote's at y equals 3. Now, for the y-intercept, by the way, these are both exponential functions, is when x equals 0. So f of 0 equals 2 to the 0 minus 1 plus 3, which equals 3.5. So your y-intercept is 0, 3.5, which is here. Now, we know with an exponential function, the curve applies like so. Now, domain for exponential function is negative infinity to positive infinity, and the range is from 3 to infinity. Again, I'm graph the inverse in green, and we know the inverse of an exponential function is a logarithmic function. Now, we know with inverse, the asymptote switch, so it was y equals 3, now it's x equals 3. And we know the point was 0, 3.5, now it's 3.5, comma 0. Now, before we graph the logarithmic, let's graph the y equals x line. Because we know if they're inverses, they reflect over that line. So our logarithmic curve is like so. All right. Domain, remember domain and range switch. So domain was negative infinity, positive infinity. Now the range is negative infinity, positive infinity. And the domain is 3 to infinity. All right, go ahead and finish up example 2. All right, let's take a look at example 3. All right. It says state the transformations, asymptote, key point, domain, and range, and sketch a graph of each. So now we're graphing the logarithmic function here. All right, so let's first state the transformations. Looks like we have 2. Right 6 units and up 4 units. Now, we know from example 1 and example 2, the asymptotes for log is x equals, and it's where this number is affected. So here this tells us we go to the right 6 units, so x equals 6. Okay, now a key point. Let's use when x equals 7. So y equals log base 2 of 7 minus 6 plus 4, which equals 4. Now you notice I use x equals 7 because 7 minus 6 is 1. Okay. So our key point is 7 comma 4, so 6, 7, 1, 2, 3, 4. So we know our logarithmic curve. And keeping with the log, I'm going to do the log in green and the exponential in orange. Okay. Now, domain is from 6 to infinity, and the range is from negative infinity to positive infinity. Now, I just looked and noticed that we did the exponential, and then we did the inverse logarithmic. But here we did logarithmic, and we don't have the inverse. So let's add that to the assignment now. So the inverse is an exponential function. Okay, which we're going to graph in orange. Okay. Now, just like example 1 and 2, we want to find the asymptote and the point. And the domain and range. All right. Now, we know in the inverse, the asymptote switch. So it was x equals 6, now it's y equals 6. So okay, the point was 7, 4. Now the point is 4, 7. And we know our exponential curve flies like that. We don't want to forget about the y equals x line. Now we know that domain and range switch. So domain was 6 to infinity. Now range is 6 to infinity. And domain is negative infinity to positive infinity. All right, go ahead and finish up example 3. All right, let's take a look at example 4. All right, so it looks like we have 2 transformations. We have reflect x-axis, and then it's left 4 units. All right. Now the asymptote, we know since it went left 4 units, it's x equals negative 4. Now the key point, we're going to use when x equals 0. So y equals negative log base 2 of 0 plus 4 equals negative 2. So you have a key point at 0, negative 2. Now, logs usually go like that, but because it reflected over the x-axis, it's going like this. Okay, we know domain is from negative 4 to infinity, and range is negative infinity to positive infinity. All right. So now let's do the inverse. So the inverse of a logarithmic function is an exponential function. Okay. Now let's find the asymptote. And point. And domain and range. Now, if the asymptote was x equals -4, we know that it's now y equals -4. The point was 0, -2. Now it's -2, 0. All right. Now we know that exponential actually here. Hear that. Now we know exponential normally goes like this, but because we're taking the inverse of something's reflected, it's like that. Okay, domain we know is from -infinity to positive infinity, and range is -4 to infinity. All right, if you would, finish up example 4 and then start working on your assignment and have a wonderful Wildcat day.